I'm assuming that you already know that the sum of all angles in a triangle is 180 degrees. I made another video on this channel about 5 years ago giving a specific proof where I used parallel lines and a transversal and the alternate and corresponding angles they created to prove this property of triangles. We're now going to look at a second proof where I use a completely different method to show that the sum of these three angles is 180 degrees. I'll link to the old video in the description and the comment section. We will begin in a bit of a peculiar way by using this rectangle as a basis for the proof. I'm going to pick a point along the top edge of the rectangle, and then from each base angle I'm going to draw a line to that point. This results in a triangle within the rectangle. Let's mark the base and top angles, and I'm going to label the top angle W and the base angles X and Y. And the point at the top edge of the square that we started with is the vertex of the triangle. I'm going to add a line from the vertex perpendicular to the base. This creates two smaller triangles and splits the top angle of the original triangle. Since this angle is now composite, I'm going to remove the W and we're going to figure out how to rewrite these angles, which will be in terms of the base angles X or Y. Because the line we added is perpendicular to the base, the angles either side of the line are 90 degrees. So let's add in those right angles. And now we can try to figure out the value of each side of the composite angle at the top. Now you might be thinking that there's an easy way to do this because this is a right angle triangle, and so you have the value of two of the angles. And so it should be easy to figure out the value of the third angle in each of the two smaller triangles. But that method depends on already knowing that the sum of angles in a triangle is 180 degrees. But we haven't proved it yet, and because we haven't proved it, I can't use that to determine these two angles. We'll have to find another way. But that's not a problem. We can find a workaround by using some basic knowledge about angles, along with some other properties of triangles that you're probably familiar with. But before we even discuss properties of angles and triangles that may help, let's look at something else that the perpendicular line is doing. Not only did it split the main triangle into two smaller triangles, but it also split the rectangle into two smaller rectangles. Now because the line is perpendicular to the base and the edges of the rectangle are perpendicular to the base, obviously both edges are parallel to the perpendicular line. And that means the distance between the perpendicular line and each edge remains constant. If on the top edge the distance between the perpendicular and the right hand side edge is A, then because the perpendicular and the right hand side edge are parallel, at the base, the distance between the perpendicular and the right hand side edge must also be A. And this must be true for the left hand side of the perpendicular. The distance from the perpendicular to the left side edge, at the top of the rectangle and at the base must be the same. We'll label those with a B. Now if for a moment we focus on the right hand side of the perpendicular, we can see that there are two triangles. The triangles share one edge in the middle. Both of the triangles have the edge A. The one on the right has A on the top and the one on the left has A on the bottom. And the other edge of both triangles are just the height of the rectangle, which means that these two triangles have exactly the same edges, so they must be congruent. In other words, they are the same size and must have the same angles. Also notice that there is an angle that's adjacent to the angle Y. Y plus this angle makes 90 degrees. The value of the angle must be 90 minus Y, because the entire angle is composite, and if you add them together you get Y plus 90 minus Y, which is equal to 90 degrees. But this is the angle that's opposite the edge A in the triangle, and because these two triangles are identical, and in the left hand side triangle the top angle is opposite the edge A, then the top angle must also have the value of 90 minus Y. So now we have one of the composite angles in the main triangle. Let's figure out the other one. If we look on the left hand side of the perpendicular this time, we see two larger triangles. And we have exactly the same situation as with the smaller triangles. Both of the triangles share the diagonal edge. They both have the edge B, and the remaining edge is the height of the rectangle. At the base, we have the angle X, and we can see that there's an angle adjacent to it. Let's show that. You can see that the sum of these angles is 90 degrees, and so the value of the unknown angle must be 90 minus X. because if you add 90 minus x plus x, you get 90 degrees. And in this triangle, the angle 90 minus x is opposite the edge B, and because the two triangles are identical, in the other triangle, the angle that's opposite the edge B must have the value 90 minus x. And now all that's left to do is to calculate the sum of all these angles. So we have x, which is the base angle, and then the composite angle is 90 minus x, and we're adding 90 minus y, and then the final angle is y, which we add. Hopefully you can see that the x and the minus x cancel, and the minus y and the y cancel, and that leaves us that the sum of angles in the triangle is 90 plus 90, which equals 180 degrees. And there we've proved that the sum of all angles in a triangle is 180 degrees. In an upcoming video, I'll show you a similar but alternative method. That's it for now. Thanks for watching.